first of all, I want to welcome everyone here that is attending our exciting webinar today with our next guest, and we at the CGMA are lucky to have him. This guy is considered to be a Swiss Army knife of technical artists in games. He is literate in multiple CG disciplines, and he has used his deep skill sets on amazing titles like Killzone, Shadowfall, the multi-award-winning Horizon Zero Dawn, and Disney's Kingdom Hearts 3, made by Square Enix, ATD. Is that the, what does ATD stand for, by the way?
It's Advanced Technology Division.
Ah, there you go, Advanced Technology Division. So he's an R&D guy as well, look at that. He's also helped a lot of indie studios like Rage Squid's Action Hank and Twirlbound's Pine, so he's very generous with the community, which is awesome, so thank you so much. Another sign of his generosity is that he's created awesome Maya plugins that are so good that they've been adopted by other game studios. On top of that, he's teaching, or he's taught at Breda University, NHTV. What does NHTV stand for? I tried to look that up. Yeah.
It's the...
Is it a hard name to pronounce?
Don't really know what it is called, because it's changed name.
Ah.
Now it's called BUAS, which is Breda University of Advanced Science.
Got it. All right, cool. Well, I figured I'd clear that up. And then also, renowned Gnomon School. Everyone has heard of the Gnomon School, so this is great. So let's give a hearty, warm welcome to a guy with over 11 years experience in the game business. Let's give a hearty, warm welcome to Perry Leijten. Woohoo! Yeah, all right, cool.
Thank you very much.
Good to have you here with us. All right. Before I get started with today's webinar, I want to thank our CG sponsor, CG Master Academy, for hosting this webinar. The CG Master Academy is a leader in online digital arts education in film, animation, and games, and we are thankful for their generous sponsorship. Perry's going to share his background and how he became a senior technical artist, and he's going to walk us through his career highlights as a scripter, rigger, bug fixer, and R&D guy, as well as some of the notable projects and workflow challenges he's faced and what his class is going to be about at the end. So at this point, I'm going to give over the reins to our guest, who has got some great stuff to share.
Yeah, so in 2007, I actually started doing my education in Breda, which is the NHTV back then, and now the BUAS, which is a university that is specialized in games. And the university actually existed for just 2 years back then. So it was quite a gamble if it actually would allow me to go into the industry, because there was no graduates yet, there was no people that actually came from that university. And the only thing that I know and what really inspired me to go to that university was because the people that were teaching there, the teachers, they actually came from the industry itself. During my education in Iran, I managed to get a hold of an internship at Guerrilla Games. When I started my internship in 2011, we just started working on Killzone 4. They were working on unannounced projects or trying to get them up from the ground. One of them was also Horizon Zero Dawn. So when I was doing my internship, I already saw that project growing up, and later on I could use that to tailor my portfolio and my specialization in the industry or in the education towards making more robots and actually doing mechanical rigging instead of the normal anatomy rigging that most people do. After the internship, I did my specialization in graduation, all done in robot rigging, researching mechanical engineering, figuring out small parts like cardan joints, universal joints, how pistons would work, and how to make something mechanically sound. This is something that I also teach in the first week of the rigging course at CGMA. I try to make people think in a different way, not just with anatomy, but also with mechanical parts. After my graduation, I went back to the school that I graduated from, saw that students were in need of help because there were too many students for the teachers to handle who were teaching modeling. So I just jumped in and actually managed to help out so many students that the teacher later that day asked me if I would want to become a teacher at the school, just to help them out with all the extra stuff that was going on. I actually got a call from a friend of mine that was back at Guerrilla Games saying they were ramping up on Killzone 4. They were deep in crunch, needed more people to actually manage to get everything done, and if I would be able to join in April, even though I still had like 3 months of teaching to go.
It's I wanted to jump in just for a real quick moment with Killzone. Did you do rigging on that project, or was it more of a broader role?
So the way that rigging went back then is we have a basic humanoid rig, just a basic skeleton, and in that skeleton all the males and the females need to exist. So as you can see here on this one, this is just as basic as it can get. There's no extra joints going on. It's a little bit difficult to see because the skeleton is not coming through. But this is as basic as it could get. And what we actually had to do is we added extra helper joints. So in this case, you see those 2 or the 4 red joints on top of the shoulder. And those are using math to pinch up when the shoulder goes down, so you get a better silhouette. And on the other one here, all these extra joints are just there for doing cloth. So at Guerrilla Games, especially with Killzone Shadowfall, I learned about how to drive a rig with mocap. As you can see, this is just a simple animation. And how to add extra joints that use the information of motion capture and math to actually enhance the visuals and the silhouette of the character. So that's something that is also part of the rigging course that I'm giving, is talking about how to use matrix information, how to use vector information to get like the most out of your character without having to key this structure, without having to do set-driven keys or like making extra information or animation data or for the game. Because if you only have to do the base skeleton as your animation curve data, that will significantly be easier for your game to handle if it knows how to solve all these extra joints with just math. So that was mainly my task within Killzone Shadowfall, is just skinning, adding extra joints, and just making sure that cloth works, adding helper joints like you can see here on the face. You have like these small local rotation axis kind of things, and here as well. And those are annotations that get exported into the game, and you can add like lights or particle effects and that kind of stuff. So
can you do me a favor? Because some of us might know what annotations are, but there might be some other people who don't. Can you explain what annotations are?
So in this case, the annotation is you have an object with a transform in Maya. It can be seen as a bone, can be seen as a transform, or whatever. And this has a specific type. In this case, we call this type the helper. When you export it into the game, it will actually see it as a transform that is called the helper. And with the specific name, you can attach something in the game later on. So if the character is moving from that point that is now moving here as well, you can spawn particles, you can attach a light, you can even attach like sound. And if the character would run around, then this would actually emit the sound. Once we shipped the game, we actually had free reign. I passed my trial period, so I could stay on as a junior artist on the rigging team. And then we had free reign because we went into pre-production of Killzone or of Horizon Zero Dawn. Almost half of the vertical slice of Horizon Zero Dawn was already finished by a different team that didn't work on Killzone Shadowfall. So when we came in, we had to work with a game that was half the assets of Killzone Shadowfall and half the assets of what later became Horizon Zero Dawn. So the rigging team actually took the first 6 months to develop a new rigging system that could not only make sure that all the humans were going to be able to be rigged. So we actually got rid of the rig that you have over here, and we basically built an entire rigging system. But it should also had to work with the robots that we're going to create. So we built a system that works in different components, and you just basically set them together in Python, and then later on you can export them to the game and even combine different parts from different robots together and save information from data. So if you have a horse and you have a bison, you can actually transfer the data between the two rigs because they're built from almost similar data. So here you have the bison, and some of these animations are actually shared between the different archetypes. So if you have like a horse or something that's quadruped, most likely it will share the same walk and run animation. Sometimes even a jump or that kind of stuff. And then others like the crab, those are all hand animated from scratch. And all these cat-like or tiger-like creatures are sharing like maybe, if I have to guess, 60% of all their animations.
It's hard to kind of like, because the shapes look so different from one character to another that it's hard to believe that they share that much between them. But
Yeah,
that's
so,
pretty amazing.
Yeah. The idea behind this system is we use the same joint names, we use the same skeletal hierarchy, we add a couple of joints here and there, but all the controllers have the same naming, and all the controllers know exactly where they come from. They know if it's a spine or if it's a left arm and a right arm. So it's really easy to transfer animation between the two. There's some retargeting going on. It's based on simple constraints like parent constraint, point constraint, and orient constraint, and then it just bakes down the animation back to the new character. And as you might notice, all of these don't really look clean in the model. So what was happening is, because some of these models were too high res to actually work in Maya, what we did is we have a ZBrush model. That's the model that comes in at the time that we want to work with it, or when we want to make the rig. Once we get the ZBrush model, we know exactly where to place the joints. We know a little bit about the skin bind information. We just decimate the model until it's to an acceptable level, that you can actually rig it and it can actually move. And we already start rigging before even the final concept is done. So a concept artist or a concept sculptor gives us the sculpt of the model. We decimate it, we rig it, we see where the problems are. We go back to the concept artist or the concept sculptor and say, this object here is clashing with another object. This is not something that we can actually make work properly. So if we cut the shape here, or if we make this part a little bit more rubber, then we have a concept that is actually viable and looks perfect for the way that it needs to move.
Hey Perry, we have a question from Cesar. Were these extra joints added on in a Maya rig or an engine rig?
So all of the joints were actually added into the Maya rig. And the math behind it was actually something we call the core node. So we had a node that translates game engine code into a Maya node. So you have the inputs and outputs are just the way that Maya handles them. But the background or the core of that node is the same as simple DLL in the engine itself.
Mm-hmm.
So once we export the character into like the game engine would pick up, oh, I know that I need to use this piece of math to actually execute on this joint, and we could tag them as we could tag an export or a joint on export to be animation viable or not to take in any animation. And if it doesn't take in any animation, then it will look for this math node and then actually know in the engine how to use the animation data to move the joint in the engine.
Hey, there was another question from the audience from Brian Evie. I guess in the export process, does the game rig get dropped by the time it arrives in the engine? And I guess the question was, is the engine aware of a rig?
So the way that we use Maya in this case is we have a clean skeleton that is attached to the rig.
Yeah.
And that clean skeleton is the one that's getting exported. So all the controls, everything that we do in Maya just gets discarded, and we just have a skeleton with a skin bind, and that is exported to the engine. But on the other hand, it is possible to have an engine rig. I know that, for instance, Bungie is doing something like that. So you actually have a rig in Maya, which is exactly the same as the one that they have in the engine. And the animators can actually work with the rig in Maya and use all the tools that you have available in Maya, but they can do the tweaks later on in the engine if they have like cutscene, or if they have like a specific move that doesn't work for a specific skill of a character, then they just move it a little bit around. And I believe the rig is completely shared between all the different archetypes. You can have a guardian that has a specific move, and then you have like one of the brutes that you can just transfer the animation to in the engine, and it will do the same animation as the guardian. So it depends on the workflow of the studio that you're actually working with, but it is definitely possible.
Yeah, I've not heard of that trend, but it's interesting because they're doing so much now in the game engine, even just compared to just a few years ago. Has the process for rigging changed in the last 10, maybe 15 years compared to maybe what it used to be like, or the core concepts for rigging, whether it was games or even film, have changed much since then?
So rigging hasn't really changed all that much over the years. Like there are some new techniques. If you have a tutorial that you can get like from 2006, I believe most of it is still viable. Most of it is still the way we rig now. We just have a little bit more extra added options onto it. So we can do stuff with especially since now 2019, we can do stuff with Bifrost. So we have our ways of making our own plugins without even knowing about C++ or Python. But yeah, rigging is now more into the technical area where we actually need to make our own plugins and our own Python nodes or something to enhance the rigs a little bit further. We can push a lot more data to our to Maya. So the rigs get like more enhanced, more bigger. We can have a lot of polygons pushed with skin clusters at the moment. If you go for film, then you would add like extra deformers on top. So the basis is still the same. The basics for rigging in games is also still the same as for rigging in movies. It's just that depending on which studio you're working at, if you're working at like example Weta Digital, then you're not just doing the basic rig, you're also working with how muscles, how fat, how skin, and everything works together. So yeah.
No, I was going to ask you a question with regards to, you know, the part of the rigging process that I remember being very tedious, which was painting weights. Is that one of the reasons why you created your plugin for painting weights a few years ago? Or what about it that, I guess, what was the problem you were trying to solve with painting weights with your plugin?
So when I started the rigging, the one thing that was the most difficult and was the most prominent feature of rigging is painting skin weights. You can make like the most perfect rig that ever existed, but if your skin weights are not there or not as clean, your rig will always look broken. Mm-hmm. And the problem that I had with Maya painting skin weights is it's very restrictive.
Yes.
and it's very buggy. So sometimes if you have like you need to work with a tablet because it works with pen pressure, and sometimes you have the problem that your pen pressure doesn't register completely, and then you get spikes, and then you have to tweak that again. So a process that, in my experience, should not take longer than 1 or 2 days can become something that is like a week or 2 weeks of work. And when I started creating my skinning tools, it was basically for really simply just forcing certain weights on certain positions and then locking them so that if I would go into painting the skin weights, that I don't break whatever I already did.
Is that something you could easily show us, or is that an involved demonstration of doing that? And is that part of the course that you are planning on teaching?
Yeah, so it's actually part of the course. I'm going into the skin weights, but yeah, there's so many specifics going on in this tool that I'm probably only speaking about maybe 25% of it.
Mm-hmm.
But one of the most powerful features, I'll just quickly create something in here. And it's a very easy demonstration. So I'll just create a tube. Add a lot of subdivisions. I'm not too bothered with how it looks. I'll just smooth bind my skin. So normally when you have skinning and you do the default bind skin, you actually see that this crease is kind of getting in there because it's trying to do an influence between the two joints over here. And if I would go in and skin paint that, so with the paint weights tool, you have this big brush and you can actually paint it. But as soon as I start painting here, because my brush is too big, it actually takes away from here. So you're in constant battle, or you need to go in and actually go in a real small brush and then you paint it in there. And I found that tedious because why have the brush if it's easier to just go in per vertex? So now I have a selection mode and I just select the components that I want. I middle mouse click on top of the bone and I can adjust the values right here. So I can quickly set this one to 1, expand it here, set it to 1 over here, and then work with the weights in between. And I have a smooth option in here, which is called average, and that smooths it in using the curve that I have over here. So I can even change the curve here, and that should change the way that this looks here.
That was so fast. I mean, seriously, I was like, I mean, that's really like unbelievable, because I remember how long it took to do just simple spots like that, to be able to get that elbow bend as fast as you did. Just that's great. That's
the only thing that this relies on is that the topology of the mesh is good. Otherwise, it will take a lot longer. But at the moment, if I have to do a full character, depending on how much polygons it is and how detailed the extra objects are, I could probably skin a character in a day. Same as with Horizon. I did almost all of the NPC characters. Think about a good 90 to 95% is all done by me, and there was about 5 hours to 8 hours per character on skinning.
So just for the record, when I went to school and I was learning rigging, it was a full month course, and I remember the weights, doing painting of the weights for my character was definitely more than a day. Try like maybe 5-6 days to do it right, you know, and without the benefit of your tool. So this is pretty fabulous. And I'm sure there's more to the tool than you just showed us now. So thank you for sharing that. Where do you have the skinning tool?
So it's gumroad.com/Kirke.
Yeah.
So you can go to my Gumroad, which is gumroad.com/Kirke. And there you have my tools. So you also have the skinning tool, you have a control curve creator, especially for rigs. I have 2 rigs available, a model error checking tool, and some extras. Some of them are like still R&D, they are not completely workable, but it's getting there. And everything is just for free or on donation basis. So, and I try to keep everything for free, because it's been helping me for so long. It already made its money. So
That's fabulous. Thank you for doing that. I know that the audience is going to appreciate that. We have a couple of other questions that have arrived since we've been talking about this. Athos was asking, if you were to rig some animal creatures, tigers, etc., for real time with some feeling of muscle, fat, etc., would you prefer to rig extra deformation joints to be animated in DCC, Maya, etc., or in Engine? Some pros and cons.
That actually depends on the studio that it is for. If it's something I would do on freelance, like based on what I do in Maya normally, I would try to do it as much with extra helper joints, extra help controls, like using NURB surfaces to detail out the muscle parts, and then using controls to actually add the jiggle on top of those NURB surfaces, and those NURB surfaces would then probably drive joints to show the muscles. If it would be for a game, then it would be actually up to math, or maybe I would use cloth-based jiggle deformers, something like that would be present in the engine as well, because then you don't have to worry about adding extra animation data on every bone. But yeah, if it would be for film, then it would be completely cloth-based, and I would probably go for like a muscle-based system. But then it depends. I would probably try to stay away from Maya muscle as much as possible, because it's good that it exists, but the end result is not always what you want. So you might want to tweak the muscle surfaces as well, to add the extra deformation that you need. But I try to steer away as much as possible from the dynamic attributes that Maya has, and I would specify the dynamic nodes or the dynamic tools that you have in a game engine or in the company itself, because you have the person that actually built those tools probably sitting in the same company. So you have the right person to ask questions, and also to hassle if you find bugs or if you want to have something new.
We have the questions are really starting to come in, Perry. So I guess talking about getting underneath the hood, opening up Maya the way you did is definitely prompting a lot of questions. I don't know if you have other cool stuff like that to share, but I'm going to ask a couple of other questions right now. Brian was asking, do you start out with weights from another character and then polish from them, or do you start from scratch each and every time?
I mainly start from scratch almost every time. If you have the workflow that we had at Guerrilla Games, then you have like a base character, which is just the naked body of either the female, the male, or the children. Those would have like a basic skin cluster already set up. We would probably polish that as much as possible, and then transfer the data over and clean up the minute details in the cloth on top of it. But for characters that, for instance, that I work together with Ben, what I try to do is get the model as fast as possible from him. So similar workflow as what we did at Horizon is he is already sculpting. He has a high detail sculpt. I request the decimated version so I can get something that actually runs perfectly on my computer. I can place the joints. I have an idea on what the silhouette is going to be, and I already tried to skin the decimated version. And it's going to be very rough, but you can already get some good shapes going on in there. And then when the high detailed version comes over, I'll just copy the skin to all the parts that come in from the high detail. And that would, yeah, then I would already hit the ground running, so to say.
Ahmad Furqan was asking, after getting any character rig, how do you plan and what is your step-by-step process to do it?
So most of the time it starts already when Ben shows me the first screenshot of what he's doing in ZBrush. Yeah, so we both already get hyped on seeing what this character could do, what this character would be of type. If it's lean, would it be fast, would it be so for instance, I'll just open up the smuggler. So the idea is Ben sends me the first draft or the first image, sometimes even just a drawing of what he wants to do. And we just, we talk a lot on Slack. We come up with a conclusion on what we want to do, what the character needs to feel like, what we want him to be as in terms of his skill, his profession, and so this guy actually started out without the glasses, without the armor parts. It was just a bust. And Ben showed it to me because he was like, I've been working on this for a couple of days now, and I'm thinking of turning it in, and it's done. And I was like, well, this character is super cool, so why don't we just complete it and then add a rig to it? And then we started actually discussing the possibilities, and we added the glasses, we added a little bit of the armor parts, but yeah, that still didn't look completely cool. So we have something like this. And then we were talking about having this Marty McFly from Back to the Future kind of feel. So you have this cyberpunk style alien with having references back to the 80s. And that's how actually the jacket came in. So we are actually trying to talk a lot about what would be cool elements, not just from a modeling standpoint, but from a rigging standpoint. And we're trying to hype each other up to get as much as possible in such a character to enhance both our portfolios, but also for both of us to do a little bit of research and development at the same time. So we get stuff like Ben coming up to me, is it possible to add like plasters on top of like skinning, and the skinning is not the same same topology? And that prompts me to actually enhance the skinning tools again to make sure that this type of stuff is actually possible and that it still looks good without me having to do like perfect skinning underneath. So it's a lot of back and forth from concept phase on, and even then when we have like some parts already rigged and something is already modeled, we go in a little bit further. So if I select the jacket here, then we have these parts that come off. Like, how would we actually make sure that this looks good when it comes off, and how would we split up parts when we actually rotate all these little parts away? And then where would we break the plates, and how would it actually move and fit together? So it's not just about looking cool, it's also about, is it believable? Can we make sure that this looks like it actually moves the way it does? So yeah, that's mainly the way that we do it. It's, I believe a character like this, I could have the base of the rig done within 2 weeks, and then I'm still working with the decimated model. Go back to Ben, say if we cut up these parts, make sure that all the metal parts are like separate, Then I can add in some extra information on deformation. And then Ben goes and does his trick and makes sure that everything is set up the way it is. And I will still get them back, all these parts, based on decimated models. And then later on, when I get the clean versions, I just copy over the skinning, and then it is mainly done. And I have to just clean up the topology and the skinning on some of these parts over here, especially in the armpits. But it saves me a lot of time already.
We have a couple of questions that came up about the tool set in particular, your skinning tools. Obviously, you made the tool set, but they want to know, how did you learn how to make the tool set? How much of that is a coding background, and how much of it is using kind of the basics of Maya Foundation stuff, you know, cutting and pasting scripts and assembling them together? And what are we looking at here?
So most of it is just, you just start doing. In Maya, you start skinning, you start working with tools that I already have. But for instance, I have this average button here. What it actually does is you can select 2 points. Let's see if I can manipulate that here. So you have a point over here. And I'll select a point over here. And then the last one I have will just get the average position between the two, based on the linear. So let's try that again. So this would be the average position between the two. The way to go about this is knowing exactly what goes on in the weights of this vertex. So let's see, I accidentally removed the top bar, so let's see if we can get it here. Windows, General, Component Editor. So to know what's actually going on in skin weights, you need to know what skin weights do. Let's see if we can. Okay, it's not really clear here, but so in this case you have weights set up for each joint on this particular vertex. So if you change one of the weights over here, you can actually see that the command is popping up here. And from there, you now want to know what is skin percent actually doing. It's showing that the value for the joint is set to 0 on this specific skin cluster for this specific vertex. So what if I have 2 other objects, and I want to have, on the last one that I select, I want to have the average between. So you have these 2 lists, and in Python it's really easy to combine lists and then divide them in 2, and then come up with a new list of values. And that's the only thing that you have to set. And then it's just from there you just go, what if I have multiple objects, and then do the average. So you go a little bit deeper in the math, and you come up with all these ideas on, for instance, I have 2 edges over here, and I have 2 edges, or an edge, part of edges here, part of edges here, and then add average, and it just runs over the edge. So all these little ideas are basically me thinking, what would be the next step to enhance this tool? How can I make it a lot easier? Because having this, to do this, and then do an average, and then go average in here, go average in here, doesn't really work. So next step, if I do all of this, can I traverse between the edges on these 2 points and just do an average? And then it should average out in here. So let me show how that looks in here. So if I would select this and just do a copy. So now this is all using the same value as this one. Now I have to select the start and end. I'll just do average, and it just averages out all the vertices in between. That's handy, but you don't want to do that for the entire arm. So in this case, I'll just copy this over. What you want to do is you select edge loops and you just run over them. and you let the tool do the talking.
How much of the time savings with these sort of like evolutions of these little nuggets of Maya's basics, like from a time factor, have you been able to see in terms of, is it twofold, is it threefold compared to, you know, suffering through sometimes the baseline tools?
Well, sometimes you have like little mistakes that can happen that would, if you would do it with normal skin painting or it might take a week, and just having the click of a button, even if it has to calculate for an hour, it's an hour you can do something else while the program is doing all the work for you. And I think, especially with rigging and technical art, that's where the power lies. You want to do, it's something that my teacher once told me, and something that I highly believe in is, I'm a very lazy person, and I work really hard to become that lazy. And I think that's the mantra of technical art. Like, you want to do, if I need to do an operation, like adding a locator for each joint in the scene, I can do that once. Maybe I just need that only for this one project in my entire life. But I would spend more time creating a script for it than doing it by hand, because if I make a mistake by hand, I have to start all over. And if I do it by script, I can just do it on the fly. If it's not what I wanted, I can just change the script and redo it. And then each time, each iteration is faster and faster.
Will you be able to, I don't know what the extent on the class that you're going to be teaching, but will some of those concepts be giving students an opportunity to kind of try a little bit, maybe in a small way?
Yeah. So for instance, the way that we set up like FK controllers, or like it's not really tedious, but it's stuff that comes up in a lot of ways, because we have FK controllers, for instance, here in the arm, in the fingers. We can have FK controllers on the legs or on tails. Sometimes even FK spine. So it's an operation that every time for each joint you need to make a group, you need to make a controller, you need to make sure that those are at the same position as the joint, and then you make sure that the joint will follow whatever the controller is doing. It's not a time-consuming process. It's just a little bit boring to do that over and over again. So I teach the students on how to create a script to actually loop over all the joints, do whatever I just say, like make this macro script, and then even enhance it. Like if I already created control previously, I just want to make sure that this control is now part as a child from the previous control. So you already get a hierarchy going on. There's scripts on how to add specific attributes that you're not able to do with just the Maya UI. I try to go into the nodes as well, like teaching people about how to work with vectors, how to work with matrices. Something cool that's happening right now is in the current class that I'm teaching, someone is actually taking all the tutorials that I'm making, and she's not rigging the character per se by hand, she's completely doing it by script. And that's a very interesting approach, because she is already thinking ahead, like, I want to do this over and over again, but I don't want to start from scratch every time.
That's awesome. And, you know, I think that's, you know, some of the best, you know, things you could do to kind of save the most valuable commodity we give this industry, which is our time. So if you could figure out that kind of ratio of savings, that's pretty amazing. Farik had a question with regards to the skinning information when you're copying over things. He said, when you copy over skinning information, how do you avoid the transfer interpolating incorrectly? Is it working well simply because your density is pretty high in both cases? Or is there fancier stuff going on here?
So that's a good question from Freek, and a shout out to Freek because he was at the same education as me back in the day. So what we actually have is you have a polygon over here that has, for instance, 4 points. if I would land a polygon with a point that is exactly in the middle, what it actually tries to do is it tries to triangulate that point based on where it is in the distance from all these 4 points. And as I did with the average weight over here, it actually tries to calculate how much percentage of this distance do I need to get, how much percentage of this distance do I need to get. And with the triangulation, it knows exactly how to smooth the weights between these 4 points. Then if you get like a higher density or lower density model, it will not always be perfect, but it would give like the best possible solution for that transfer. So if I would create a plane over here and just copy this over, copy pose, and I would now rotate this around. It already tries to follow whatever I just did as much as possible. So it takes the closest vertices into account. And as you can see, it's trying to stay, like for instance, this point is trying to stay at the same distance from that point as much as possible. So it's using not just the data of a single vertex, it's using the triangulation data of all the components that it's within.
Alex has got a question. He says, how far do you think we are for real-time skin and muscle simulation? Things like Ziba, but in real time.
I think for games, at least, it will stay with just regular skinning for a long time because it's the cheapest way at the moment. There are some interesting new ways to prevent volume loss and to get better deformations off the get-go without using all that much extra skinning on top. But yeah, it's the cheapest at the moment, and you want to like have as much possible on your screen. Like if you have a war going on, or like in Horizon, you want to have as much robots or as much NPCs being drawn on the screen at the same time. And having real-time skin for games, that would really take the performance out of it. But real-time skin for movies and that kind of stuff, I think that's already being developed at the moment, because people are already looking into having a mocap camera and just walking with the camera through the screen or through a scene. And the scene can be like a barracks or like something that's like completely barren, nothing going on. And then when you look into the camera or in the tablet that they actually move around with, you can actually see the entire scene that they already built up. So I think in that kind of sense, they might actually go into that real-time direction. Yeah, should not take 10 years, I believe.
We have a couple more questions. I just looked at the clock and we're at 5:30. Time flies when we're having fun here with learning all this great information. So do we have time for a couple more questions?
Yeah, I have plenty of time. So.
Okay. Okay, I'll do a quick one. Thiago was asking, will you still be teaching the same rigging for games course?
Yeah, so I'm set for the fall course right now. I already set up the fall or the course for winter. But depending on how much people are actually attending, I'll just keep this up because it's a lot of fun to do.
Okay, perfect. Thank you for answering that. We have Michael Vaughn asking about whether or not a 3D modeler should learn rigging. And I already know the answer to that one because I was a modeler and I love rigging tools, but I'll let you answer.
So it all depends. Like, do you want to become better at your job? If you don't want to learn rigging, then that's fine, but you would not become as popular or as wanted for different type of industries. The more that you know about what a rigger does, you don't have to like make a perfect rig. You don't have to be a perfect rigger or animator or whatever to do your job well. You're still a 3D modeler. But the more that you know about what goes on in the process of all the other aspects in the game industry, the better that you will be at modeling itself. Because you will understand that certain movements are not possible with the model that you're creating, or how to make a model that allows for the movements that you actually want, or that the concept artist has envisioned. In that sense, I also think that a concept artist should know about what a model does, or what goes on in animation later on when his model has been through all the stages. And one thing that I think is even more important is everybody in the industry should at least know a little bit about scripting. Know what you can ask from a tool creator, or even that you don't have to hassle a tool creator, because the thing that you're actually asking is a 5-minute job for yourself. So yeah, the more that you know, the more versatile that you are. You don't have to be perfect in it, just know a little bit about it. That's my idea.
One other question, what is the skill level or skill set that for this particular rigging class are you hoping, I guess, to see from people? What is the learning requisite?
It is a master class, so in that sense I put it up that it's quite fast paced, but I do explain the basics in the first week as much as possible. So the minimum requirement, I think, is that you need to know how to work in Maya. And if you worked in a previous or in a different application, that you won't get hung up on transferring to Maya. Because people are still able to ask questions like, how do I do it this certain way? Because I'm used to do it in Max, and that doesn't exist, because that's fully possible.
David Ferreira is sort of a statement and a question all at the same time. He says, I'm building my own learning path, and it goes something like this: linear algebra, Newtonian mechanics, MEL, Python, and what other knowledge do you recommend me to add to be a technical artist? And he added, learn Houdini is on his wish list. So I guess you kind of sort of answered that already in terms of the more you know. But if you were programming a learning path without the benefit of going to university, I mean, that's an interesting choice of classes and that he's choosing for himself.
It's very math heavy, what he's, it's a little bit more on the technical side, what he's talking about. But as a rigger, especially technical artist in a rigging sense, you should not forget that anatomy is very important. You need to know about not just human anatomy, you need to know about animal anatomy. You need to start thinking in terms like, how do muscles work? If you want to do something with faces, learn a little bit about FACS, like facial action coding system. But I think the base path that he set out is a really good start for at least the technical arc side and tools.
The couple more questions that came in, and some are kind of related to career. Nicholas Mooney is asking, how's employment like for technical artists in Japan compared to working in other countries? I'm looking into Montreal in the near future, but Japan for the long term. What's that like?
So Japan is a little bit of an edge case. I'm very lucky at the position that I'm at because I'm part of a research and development team, which means that it's 50% foreigners, 50% Japanese people, and we're not required to speak the language. We are taking classes, they are all paid for by work, but yeah, most other companies in Japan, there are some that actually hire foreigners, but most of them, they require you to have like a business level of Japanese. And I'm not even close to that at the moment.
Okay, it's good to know because, that's the reality of being in another country, All right, terrific. Let's see. What type of features in a rig, if you're trying to, show off what you know, what type of features in a rig is good to show in a demo rig?
So the one thing that most people do is they show every little control that has been done over and over again. Try to stay away from that. Make sure that you show that your rig is animatable. Get an animator or animate it yourself, and make sure that you make some really cool animations with it that show off all the features of your rig, or at least all the base features of your rig. Moving the arms, moving the legs, maybe run and jump, that kind of stuff. And if you did research and development, like you made a specific part of the rig look really cool that you haven't seen anywhere else, then you can highlight that. And maybe highlight that in the animation, or just at a standing still model. But just showing the rig by moving controls, almost nobody wants to look at that. It's tedious, and yeah, most of the time a waste of time, because a lot of other rigs have the same features. So yeah, having like this one or two things that are very special and the complete animation, that's how I would set up a demo reel or something.
So that, I guess in that question, this Ahmed's question almost kind of gets answered automatically. So how much rigging knowledge should an animation artist at least have to understand in any rig better? I would say, to me, that's like a modeler not knowing how to texture. You know, it's like neighboring disciplines, you know. But what's your take on it? Is it similar to the modeling question? It's just the more you know?
The more you know, the better. Then again, an animator should not always have to know exactly what's going on under the hood, but should know a lot about the technical terms. Because as an animator, you're actually working very close with a rigger. You're working closer than the modeler or the concept artist or anybody else. You're the one that's actually requesting features from a technical artist. So you being able to understand and explain completely what you want, even if it's with examples from different rigs that you found online, or that you have like from previous companies or whatever, as long as you are allowed to show them and you can make clear what you want in your current rig, then that's fine. You don't have to know how to rig a character from scratch, although beneficial. You do need to know all the technical terms.
Okay. We got two more questions, and then I'm going to kind of call it off there. They're pretty short. One of them is going to be, can a rigger be successful if his knowledge in math is not as high as maybe, you know, some people think it should be? What level of math are we talking about when it comes to rigging?
So you can get around with not knowing all that much math. For the first couple of years, I didn't really know math at all. I was very bad at it in high school. But gradually I learned more, because it's actually more fun to work with math in 3D. And I actually understand the way that vectors work, the way that matrices work, and even to some extent how quaternions work, just based on how I use them in Maya. I have a clear sense on what the math is doing, because I've seen it repeated itself over and over in a 3D space. And that's how I learned most of my math. If you want something very complex, you might not be able to ask me on how to get it done. But that's why I have all my other colleagues that are more into heavy programming, heavy math, and actually doing like the heavy computations on IK kind of stuff. I would go to them and ask like, hey, I want to have this and this and this. I'm using a workflow that has this going on right now. Where am I going wrong? So if your knowledge of math is not up there, it's understandable, and you will have to rely on your colleagues every once in a while. It's not that bad a thing.
Well, this is great. This is the last question, and then we're going to call it a night. But Cesar Souza asked, do you usually use blend shapes in your IRGS? And for what situation?
So I try to stay away from blend shapes as much as possible. even though the rigs that I do together with Ben, they are never going to be released in a game engine, so it should actually be fine. But and I'm quite confident in my sculpting techniques, but if you then see what Ben actually creates, then I would much rather ask Ben to create the blend shapes for me. But I think the challenge is more like how far can we push skinning, and how far can we push joint-based deformations instead of going for an easy way out where we just move vertices to a position that we like. And then again, yeah, sometimes for games you really need it because otherwise you don't get the fidelity. But I'm actually trying to figure out ways how to get rid of blend shapes, because for every blend shape that you have, especially in faces, you have like the FACS, which is fax-based or facial action coding system-based deformations. So every little muscle has their own blend shape. That will add a lot of memory into your game. And I'm currently thinking of ways on how to reduce that, or even how to get rid of it, because you want to use the memory in the game for other stuff to get more stuff out there.
Okay, well, I guess we have literally emptied the chamber, so to speak, with the questions. So I'm thrilled, and I just want to thank you first of all, Perry, for just taking the time out on a Saturday morning when you should be eating pancakes and eggs or whatever you usually eat for breakfast. This is definitely an early, early-ish rise for the day that you're usually off. So I'm just going to say thank you for taking the time. So on behalf of the CG Society and CGMA, we just want to thank Perry Leijten for this amazing past hour plus of sharing his background and his insights and all things rigging in games.